Good morning to all. I'm Dr. Amina Priyadarshini. Today's class we shall discuss about the communication systems. The topic on amplitude modulation. Okay, the first one, amplitude modulation. It's a continuous time modulation. So, by definition, we can say that the amplitude of the carrier signal is varied in accordance with the amplitude of the message signal. So, here the message signal is named as modulating signal. So we can say that for a modulator which has two inputs, one is the message signal, another one will be the carrier signal. So the message will be a low frequency signal and the carrier will be a high frequency signal. So when these two signals are transferred through the modulator, the output will be the modulated signal. And in case of amplitude modulated signal, the amplitude of the carrier is get varied in accordance with the message signal. So that the frequency and phase components of the carrier signal will remains constant. So the only variation will be takes place in the amplitude term. So this is a waveform for amplitude modulated signal. The first one is the message signal. So here we have considered the message is a continuous time signal. A cosine signal is considered for a particular time duration. So which has an amplitude of AM. And next is the carrier signal. So the carrier signal, it also has a particular amplitude and frequency. So since it's a high frequency signal, so within the allotted time duration it has number of cycles. So this carrier signal is also considered here as the um, cosine signal. So once these two signals are transmitted to the modulator, the output will be the amplitude modulated signal. So the third figure is the AM signal. This amplitude modulated signal, here you can say that for the particular allocated time duration, the amplitude of the carrier signal is varied. So when compared with figure 2 and 3, the amplitude of the message signal is amplitude of the carrier signal is get varied, whereas the frequency and phase of the signal remains constant. So which is represented exactly in the graph. So when we trace the envelope of the amplitude modulated signal, the envelope consists of the message signal which we have transmitted. So we can say that this is the cosine signal, message signal. So when we trace the envelope of the AM signal, the envelope will remains the same message signal which we have transmitted. Next is the mathematical representation of amplitude modulated signal. So since we have considered two signals, one is the message and the carrier. So here we are representing the mathematical expression of the signal which is in time domain. So first of all, let us consider the message signal. So message signal is named as, other name of the message signal is, we can represent it as modulating signal or input signal or baseband signal. All these things represents the message signal. So here the message signal, which should be a low frequency signal. So let us consider the message signal m of t as am cos 2 pi fm t, where am is the amplitude of the message signal and fm be the frequency of the message signal. So it is a low frequency signal. Frequency will be a low frequency. Next, we shall represent the carrier signal. So carrier signal is indicated as c of t. It is also a cosine waveform. So AC cos 2 pi FCT. So where AC is the amplitude of the carrier signal and FC is the frequency of the carrier signal. Now these two signals are transmitted through the modulator. So the output of the modulated signal, output of the modulator is the amplitude modulated signal, which is indicated as S of t. So here the amplitude term of the carrier is get varied, so that they can say that, and you can represent CFT as AC plus the message signal M of t into cos 2 pi FCT. Therefore, instead of M of t, we can use the message signal. Therefore, the amplitude term of the carrier is get varied. So AC plus AM cos 2 pi FM t into cos 2 pi FCT. So when we are multiplying these two signal, it's the modulation index. Next is the modulation index, which indicates the depth of the modulation, and it states the level of modulation that a carrier waves undergoes. So when we are rearranging the above equation, S of t can be represented as AC into 1 plus AM AC cos 2 pi FMT into cos 2 pi FCT. So here we are replacing this AM AC by mu, and here AC into 1 plus a mu cos 2 pi FMT into cos 2 pi FCT, where mu represents the modulation index. So mu, the value of mu is equal to AM by AC. So from this, the depth of the modulation is indicated. It is of three types. One is under modulation, next over modulation, another is the critical modulation. So if the under modulation means the value of mu will be less than 1, and over modulation means the value of mu will be greater than 1. If the value of mu is greater than 1, both the positive envelope and negative envelope of the signals may get overlapped, so we cannot receive our signal properly. And in case of under modulation, the value of mu will be less than 1, so the signal will be properly traced and we can recover our signal. Thank you.